Welcome to Manufacturing Processes, Machining and Machine Tools lectures by Professor Joyjeet Ghosh. This is the 13th lecture of a series of lectures. This lecture will be on milling machine and related aspects. Part 1. He will be discussing about milling, types of milling machine, column and knee type milling machine components, size or specification of a milling machine, work holding in milling, tool holding in milling, milling machines attachments and milling cutters, like plane milling cutter, side milling cutter, angle milling cutter, form milling cutter, slitting saws, end milling cutter, face milling cutter. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access my videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture. In this lecture, we'll be discussing about milling machine. So this lecture is actually divided into two parts, part 1 and part 2. So in part 1, this lecture, we'll be discussing about what is milling machine, and what are the different types of milling machines. We'll discuss about milling machine specification, work holding in milling machine, tool holding in milling machine, different types of milling cutters. All this will be discussed in this lecture. In the second lecture, we'll be discussing about the nomenclature of a plane milling cutter. We'll be discussing the different types of milling operations, up milling, down milling we'll be discussing, and we'll calculate the machining time and some solved examples on machining time calculations of milling process. That will be in part 2. So let's start with part 1. So what is the milling process? Basically, milling uses a multi-point cutting tool which is rotated at high speed and fed to a workpiece. This multi-point cutting tool removes material in small quantities by each teeth, and the end result is a high material removal rate is achieved. Now, what are the operations for which we will be using milling process? Milling machine or milling processes can be used for generating flat surfaces. It can be used for generating pockets. It can be used for generating 2D surface. It can be used for generating 3D surface, helical cuts, normal straight slots, slanted slots, slanted surface. So various gears, various types of operations can be performed on a milling machine, and therefore milling machine is very versatile. The reason it is versatile because there are a large number of cutters that are available, and there is a large number of attachments that are available in a milling machine, which makes this machine one of the most important machine tool in a machine shop. So plane milling machine was first invented by Eli Whitney in the year 1818, and later on Joseph R. Brown of Brown and Sharp Company invented the universal milling machine in the year, I think, around 1860s. Joseph R. Brown of Brown and Sharp Company invented the universal milling machine. So what are the different types of milling machines? Column and knee type will classify into three basic types, basically column and knee types, bed types, and special purpose milling machines. So column and knee type milling machines are 4 types. Bed type milling machines can be simplex, duplex, and triplex, and some of the special purpose milling machines which are not that much popular are planar milling machines, profile milling machine, rotary milling machine, and drum milling machine. So all these will be discussing. So we'll start with column and knee type milling machines. On the figure on the right hand side is the horizontal column and knee type milling machine. It's a plane milling machine. You can see there is a column, there is a knee, and that's why it's called a column and knee type milling machine. This knee can move up and down, and there is a saddle on this knee which can move in crosswise direction, and the table can move in longitudinal direction. So there are 3 degrees of freedom. So this is called 3-axis milling machine, and this is the spindle. This spindle holds the arbor, and the arbor rotates carrying the cutter. This is the cutter. So the axis of rotation of the cutter is parallel to this table. That's why it's called horizontal milling machine. Whereas here This also has 3-axis movement. The knee can move up and down, the saddle can move crosswise, and the table can move in longitudinal direction. And here the axis of rotation of the cutter, if this is the cutter, is perpendicular to the table. That's why it is called vertical milling machine. It is also a plane milling machine. This is also a plane milling machine. But essentially, when I say plane milling machine, we mean it's a horizontal milling machine. So this is a horizontal milling machine. We have two figures in front of you. This is a vertical milling machine. This is a vertical milling machine. You can see the cutter rotating. This is a face milling operation going on. The cutter is rotating and it is being flat surface is being generated. This is a universal milling machine. You can see apart from this is the knee can move up and down, and this is a saddle here. The saddle can move in crosswise direction, and top of the saddle there is the table, and this table has a circular base, and it can be rotated about this circular base. You can see the circular base here and can be fixed at any particular angle. This is required when you want to take helical cuts, when you want to make helical gears or helical cuts. This type of arrangement is required. This type of arrangement I have said in our universal milling machine in our lab for making helical gears. So currently it is cutting a gears. You can see this is the dividing head. This is the mandrel which is holding the workpiece, and this is a cutter here which is not visible here. It is cutting a helical gear. So there are 4 degrees of freedom. So universal milling machine has 4 degrees of freedom, or it's called a 4-axis milling machine. It can move up and down, and saddle can move crosswise, table can move longitudinal wise, and table can be swiveled. So 4 degrees of freedom. And there is another type of milling machine where table not only can be swiveled like this, it can be tilted also. It can be tilted. So it has 5 degrees of freedom. So those type of milling machines are called omniversal milling machines, or called 5-axis milling machines. So omniversal milling machines or 5-axis milling machines. Then we have bed type. Sometimes the work is quite large, which is not possible to be held in a column anytime milling machine, and it requires much more rigidity than it is available in a column anytime milling machine. In such cases, we use a bed type milling machine where there is a bed, and when on the top of the bed the table is mounted. So this gives a much more rigid construction. So depending on the number of spindles, you can have a simplex, duplex or triplex bed type milling machine. So this is a figure of a duplex milling machine. You can see there are 2 spindles cutting the workpiece which is held on a table, which is held on a bed. This is a better figure. So this is the table, this is held on a bed, and this is single spindle. And you have some special purpose milling machine like planar milling machine. Here the table carrying the workpiece reciprocates. The feed is given to the table and the cutter rotates and cuts it. This is a planar type milling machine. This is a planar type milling machine. The table carrying the workpiece on the bed reciprocates, and this is the tool head carries the cutter and rotates. So we have profile milling machine. It's a very interesting milling machine where we have a template or a duplicate of the work which has to be reciprocated. It may be made of plaster of Paris or any soft material, doesn't matter. So what the stylus do is that stylus follows the profile of the particular template of the workpiece, and that profile movement, that movement of the style over the stylus over the profile is forwarded to the tool via a hydraulic mechanism. The movement of the tool is reciprocated on the movement of the stylus is reciprocated on the tool using an hydraulic arrangement, and as a result the template is duplicated on the work. So this type of milling machines are called profile milling machines. Then we have rotary table milling machine. In rotary table milling machine, it basically we use an attachment which is called a rotary table. So this is we have a rotary table. So this enables the milling machine to cut circular surfaces or cylindrical surfaces. So this table can be attached to the table of the milling machine, and it can be connected to the lead screw of the table, and feed can be given, automatic feed can be given. The table will be rotating as the cutting takes place. So this enables more number of workpiece to be machined in a single setup. And we have drum milling machine. In drum milling machine, the axis of rotation of the cutter is in horizontal plane. So it is rotating in this manner, and there is a drum. On the face of the drum, the workpiece is held, and the face milling cutter is rotating and is cutting. So 3-4 cutters can be simultaneously used and for to achieve higher productivity. So these are different types of milling machines that are normally used, but one of the most common milling machines are basically the bed type milling machine used industrially, and the column and knee type milling machine. Also sometimes planar milling machines are also used. So with this we move on to the components of column and knee type milling machine. So you can see the various components here. This is the knee, this is the saddle. On the top of the saddle, the knee is mounted. You can see the ways on which the saddle can move in this direction, and there are ways on which, on the top of the saddle, on which the table can move in longitudinal direction. And the knee is mounted on its elevating screw. The knee can move up and down. So let us have a clear figure here. This is a block diagram of a column and knee type horizontal milling machine or plane milling machine. So the various components that we'll be discussing is that here there is a base. The base is normally hollow and made of cast iron, and the other components are mounted on the base. So the base acts as a sump for the cutting fluid, and there is pump and filtration system in the column which will filter the cutting fluid which is coming back after the cut is taking place, and is filtered and is given to the supplied to the sump in the base. And there is a pump system which will pump the cutting fluid in between the tool and the workpiece. The column is also a hollow casting which is mounted on the rear side of the base, and the mechanism that is required to drive the spindle is mounted inside the column, and sometimes the controls that are required are also mounted on the outside the column structure. On the top side of the column, or the front side of the column, is accurately machined, on which the knee can move up and down. And on the top side, top inner side, there is a circular hole through which the spindle is mounted in the column. Now the spindle of the machine is another major component. The spindle is driven by the motor directly, and the spindle is hollow, and there is a drawbar which holds the arbor, and the spindle is made of alloy steel, and it is heat treated to resist any kind of to resist the wear, or to increase the wear life, and to absorb the load that is taking place during the cutting process. The bearings of the spindles are specially designed to absorb the thrust loads and the radial loads. Normally we use a combination of cylindrical and roller bearing, or it may be a tapered roller bearing. So it's very interesting design, these bearings of the spindle. Try to find it out, try to Google the bearing, what are the different types of bearing settings used in spindles in milling machines. So the arbor is fitted to the directly fitted to the spindle, and arbor carries the cutters, and these are seams to position the cutter with respect to the workpiece. So you can adjust the seam, and you can change the position of the cutter on the arbor. So there is an overarm which gives support to the arbor on the other side. Okay, so knee is mounted on the front face of the column on an elevating screw, and the knee can move up and down. So the knee can move, the z-axis movement is given to the knee, and on top of the knee it's accurately machined and forms ways for the saddle. The saddle is mounted, you can see the saddle here. So this saddle is mounted on top of the knee, and this saddle can move in z-axis in this manner. So the axis name can be varied. It can be z, it can be y, it can be, but so here the saddle can move up and down crosswise in this direction, and the table can move in this direction. So these are the major components of a milling machine. Table has T-slots on which the workpiece or work holding devices can be mounted, or directly you can use T-bolts and clamps for holding the workpieces, or you can use vices or other compound angle plates or weave blocks to hold the workpieces, or workpieces can be held using indexing or dividing head. The various ways you can hold the workpieces. So how do you specify the milling machine size? The size of the milling machine is specified by the dimension of the work surface and the maximum longitudinal feet, crossface, vertical feet, apart from the ranges of spindle speeds, ranges of feeds, and the power that is available, and the taper of the spindle nose taper is also specified, and the gross weight. So this is how we specify a milling machine. These are the common parameters which has to be specified while specifying a milling machine. So how do you hold work? Using vices. This is a plain vice. You can use swivel base vice. You can use universal vice. Swivel base vice swivels about the base and about the vertical axis, and universal vice not only can be swiveled, it can be tilted also. So this increases the versatility of the equipment or the machine. So the angle plates are used for right angle workpieces. So those type of plates can be held using the angle plates and clamps and bolts. And a rotary table, one of the important attachment of milling machine is a rotary table. So this rotary table can be rotated, and you can see it is tilted also. This is particularly this particular rolling machine not only can be rotated, it can be tilted. So try to understand the complexity of the workpiece that can be done in using this type of attachment. So rotary table is you can attach to the table feeding screw, and it automatic feed can be given, and it can be rotated during the cutting process. So this is a rotary table. You can see it is graduated here. It is fitted on the table of the milling machine in the T slots. It's a T bolt and nuts. Okay, this is the arbor. You can see the seams here. These are called seams. This is a involute profile gear cutter. So you can see in my previous setup I have shown you this is a helical gear which was being cut. You can see the helical teeth of the gear. The table was tilted, and this particular setup I have created for cutting helical gears. How do you hold the tool? So you can use collets. These are particularly useful for holding end milling cutters or tapered shank milling cutters. Collets can be fitted to the spindle, and to this collet you can fit the tapered shank of the cutter for the end milling cutters, and you can directly bolt it, or you can fit it in the arbor, or you can directly bolt it. Face milling cutter can be directly bolted on the nose of the spindle, and the screwed on cutter. Small cutters have threaded holes at the center, can be screwed on to the nose of the arbor. So with this we move on to the different types of attachment. One of the most important attachment that is required, and probably most of the milling machine has, or you should buy along with the milling machine, is a universal dividing head. Now what is a universal dividing head? We will be discussing in details in the in one of the lectures, following lectures. So dividing head is basically used to divide the workpiece in equal number of divisions. This is particularly required when gear cutting and other similar type of processes. So this attachment is a very important attachment, and we will be discussing in this about the dividing head in subsequent lectures in details when we discuss milling indexing. So vertical heads, sometimes you require, you have a horizontal milling machine and you want to carry out vertical milling operations. For that you require to convert the moment of the spindle, that is, which is rotating about a horizontal axis, to rotating it about a vertical axis. So here it converts the horizontal rotation of the spindle into a vertical rotation of the spindle. This attachment is attached to the face of the column or to the overarm of the horizontal milling machine. And slotting attachment, sometimes you want to cut slots. Of course you can cut slot by different processes in milling machine. Suppose you want to cut a slot using a slotting attachments by reciprocating movement. So the rotary movement of the spindle has to be converted into reciprocating movement of the cutting tool. So that is possible by using the slotting attachment. Then we have rack milling attachments. In rack milling attachments used for cutting spar racks and helical racks. It is also attached to the face of the column. And you have high speed attachments. Sometimes you want to operate the machine at a speed higher than that is available. So you use the high speed, the gearbox, to the face of the column, and it increases the speed of the spindle by 4 to 6 times. Then you have the universal milling attachment. It's a very important attachment, where if you are having a horizontal milling machine and you want to convert this horizontal milling machine into a vertical milling machine, and therefore just like the vertical head, it can be converted, and not only it can be converted into vertical head, it can be swiveled and it can be tilted also. So that is called universal milling attachment. And circular milling attachment, that already we have discussed, the circular table, that already we have discussed. With this, we move on to milling cutters. One of the reasons why milling machine is so versatile is because we have different types of milling cutters. The entire set of milling cutters, I'll be dividing it into two parts. First, I will be discussing those type of milling cutters which are used in horizontal milling machine, and then we'll be discussing those type of milling cutters which are used in vertical milling machine. So let's discuss the cutters which are used in horizontal milling machine. The first cutter that I'll be discussing is the plain milling cutter. So one of the most important cutter is a plain milling cutter. You can see this plain milling cutter has cutting edges on the periphery, and it is rotated, and it generates a surface which is a flat surface parallel to the axis of rotation of the cutter. So it has cutting edge on the periphery, so the helix angle may vary. You can see this is a standard helix angle, this is a high helix angle, this is a high helix angle. Okay, so these are the flutes, the gap between the teeth. Okay, so this type of cutters are used to generate flat surface. Very important, this type of cutters are used to generate flat surface, and this flat surface are parallel to the axis of rotation of the cutter, and it has cutting edges only on the periphery. So this is then we have a side milling cutters. The side milling cutters are this type. So it has cutting edges on the periphery and on both sides. It may have cutting edges on both sides. If it had cutting edges on the both sides, we call it side milling cutter, and if it had cutting edges on one side and the periphery, we call it half side milling cutter. So what type of operations can be done by side milling cutter? You can cut slots and you can cut shoulders. I'll show you while discussing the process the application of side milling cutters and half side milling cutters. Then we have stagger tooth half side milling cutter. This is stagger tooth half side milling cutters, where alternate teeth are in opposite helix. Why this type of construction? To increase the gap between the corresponding teeth so that you can take deep cut. Stagger tooth side milling cutter. Then we have form milling cutters. Form cutters, irrespective of what machine tools, form cutters are those cutters where the shape of the tool is produced on the workpiece. So sometimes we require the shape of the tool to be reproduced on the workpiece. In such cases, we will be using form milling, and for that we have different types of form milling cutters. Convex milling cutters, concave milling cutters. So here convex milling cutters, and this is a concave milling cutter. We have corner rounding milling cutter. So this is a concave milling cutter, this is another concave milling cutter. So milling cutters are available in various sizes. You can see the gap here, and this is the gap here, so it varies. So it is available in various sizes. So this is for corner rounding. Another very important form milling cutter is a gear cutter. This is involute teeth gear cutter. So this is involute teeth gear cutter. Okay, then we have angle milling cutter. For cutting angular slots, one-sided angle or double-sided angle slots, we use angle milling cutters. So these are available in various included angles and various diameters. And we have slitting saws. Slitting saws are used for cutting slots and for parting operations. That means you want to divide the workpiece into parts or cut it out, so use slitting saws. They are basically plain milling cutter having cutting edges on the periphery, but these are very thin. And we have end milling cutters. Till now the milling cutters that we have discussed, these are all used in horizontal milling machine. Now onwards, the milling cutter that we will be discussing are used in vertical milling machine. So end milling cutters are tapered shank or straight shank. These are straight shank end milling cutters. It has cutting edges on the periphery as well as on the face. So for other applications, for cutting slots, for cutting pockets, for two-dimensional profile cutting, for three-dimensional profile cutting, end milling cutters are frequently used. Now there are various types. You have ball nose end milling cutter. There are various types of end milling cutters depending on the applications. This is a 2-slot end milling cutter, T-slot. This is a T-slot end milling cutter. This is a dovetail slot end milling cutter for cutting dovetails, and this is T-slots. This is a T-slot end milling cutter. Okay, so with this we come to this end of this part of the lecture. In the next part, we'll be discussing the nomenclature of a plain milling cutter, and we'll be solving various problems associated with milling. Thank you for listening to this. If you have any doubt, please feel free to contact me either by the comment box or you can mail it to me. Thank you.